Start, anybody is using anything besides Ruby that is a functional language? Cool. Okay, so my talk is called Functionalish Ruby because it's not actually like functional programming, but it's the closest we got at NomNom. So, okay, before I start, like NomNom, we are a customer feedback aggregation company. So we integrate with multiple sources of feedback, and we try to process your data, try to make it searchable, actionable, and actually do some crazy machine learning on top of that. So we are a bit data intensive and we are write intensive. So we actually started to move away from Ruby. So this was our initial stack, which is I think it's a common one. So we had the Rails app, we had the RabbitMQ queue in the middle. So we had the Elasticsearch for search. We would write to PSQL with JSONB, and we had a lot of Ruby workers that were doing integrations, like all the emails, messaging stuff, indexing, and the data processing bit. So nowadays, this is kinda our stack. I think our CTO would kill me to show this, but because there's a lot of arrows missing here, but still it's kind of accurate. So all of those services are actually written in clojure, and that one is in clojure too. If anybody knows chicken scheme, we also have a process somewhere running chicken scheme, but you can read more about it. I'll leave some links in the end. So yeah, so basically we were migrating from the first service to first version to this one, and we were hiring engineers, and we were doing breaking our monolith. We were creating microservices. We were creating new features, new engineers. We were multi-language, and now we were multi-paradigm. So yeah, this was really damn hard. So we decided to simplify our Rails way of writing code and try to keep the less possible state in our heads while writing Ruby. So that's why we came up with this approach. So functionalist Ruby patterns were hopefully less stateful head. So okay, functionalist programming. This is one real simple slide, but super hard to do because there's a lot of different definitions. So I'll try to bring what I think is the most important, at least for this bit. So pure functions. So we try and pure functions are a function that if receives a function of X that always outputs Y. So there's no way you can memorize it. You can put it on a table. You can use dynamic programming if you want, and it will always return the same value. So immutable state, which is kind of hard in Ruby, you'll see why, because of the dynamic nature of Ruby. It gets really hard to keep state immutable, but I'll give it my best shot. And this one is not usually on the slide, but I really like it. It's declarative, so try. I think the easiest way to talk about declarative is try not to use an if and an else. If you're using it, something's probably not correct-ish. Okay, so who cares about this? This was my biggest problem. Cool. This was my biggest problem for doing the talk because who cares about functional Ruby? So I think it gives you a simpler mental model. For me, this is the most important one because they say that you can memorize 4 variables in your head. That for me it's not true. I can memorize 1 or 2. That's it. So for me, this is the most important one. It's test friendly. I don't think I have an example of a test, but I can give you one after the talk or something like that. But believe me, because you can just pass parameters and stuff will happen. You don't have to mock. Well, you have to mock, but you don't have to get all dynamic and try to replace services and stuff like that. It has simple conventions. Basically, we try just to use functions. In Ruby, it gets again harder, but we'll get there. And for the people that are less interested in functional for now, there's a really good talk that I try to leave a link where you have Aaron Peterson and you have Koichi and Matsumoto talking about guilds and all that. I think the next talk might talk about it, but anyway, they are trying to make Ruby 3 times faster, and they are talking about some concurrent models, so it might be helpful to keep that in mind. And there's also some concurrency in Rails. This is a bit biased because my roommate is actually doing some concurrent stuff in Rails and it gets hard. And there's the whole Rails application, what is it now? I think I have a note here. Executor thing that, well, if you don't use it, it might be okay, but you should use it and most people don't know about it because Ruby does some concurrent stuff sometimes. Okay. Okay, of course, fun. For fun, obviously. Okay, first pattern that I want to talk about is actually callable. I don't know, most of you are probably doing Rails, you probably are doing services because like your models are too big or your controls are too big, so this is actually something that is used a lot actually on services. So basically, okay, this is just the first structure for us to have a base to work with. So this is just an article class that receives a title, and so for now our article just has a title. So now let's look at how the callable pattern works. By the way, I'm introducing an example that is called, it's easier to show. So the clickbaiter, it will follow us along all the presentation. It's basically this class that the only thing that it does is actually remove if your article title ends up with a dot, it will replace it by integration mark, and then you have an article that is a clickbait, basically. So this is a really simple example. So the only thing that is there, you can see there is a class method where you actually create an instance of your class and you just call it. So this is pretty much the callable way. So it's super simple. There's a couple of code smells here that you'll see in a minute. But basically, the call method takes the article, replaces the final dot with a question mark, and that's it, returns the article. So that's it, super simple. And why is it useful at all? First okay, this is an example of it working, so pretty straightforward, I think. So actually, I don't think you can see the end, but it should work. How can I get my... Okay, there it is. So you have the question mark there, which is good, it works. Let me click outside. So why is it callable useful at all? So it has exactly the same interface as method. So you can imagine that you have a function that is a caller that gets some arguments and something that he has to call with those arguments. In this example I have here, I just created a method called downcaser that basically downcases the title of the article, and I can actually use clickbaiter or the article or the downcaser in the color method, and the interface is the same, so that's pretty good. You can imagine using it. You can just pass, because proc has the same, we will talk about it, but proc also has the same interface, so you can basically pass a proc there in your tests and you're done. That's pretty cool, and you have pretty much all the functionality you need on the call method, so that's a good one for me at least. So this is actually a name that I came up while preparing this presentation, which is pure function as an object. So that's Tom from Tom Dalling. He was the guy that gave it a name. He actually does one thing that is different from what we do at NomNom, but we'll see that in a second. So, okay. So some properties of pure function as an object is you have no mutation on that object. You try to keep it to a single function, so all the behavior should, all the objects should only have behavior in a single function, and try not to keep internal state. We'll see that this one is arguable, because if the object behaves as a function, the function needs to have internal state, because internal state will be basically local variables, but it's fine. Okay, so let's change our article to actually use freeze. So this is the no mutation bit that I talked before, and we're kind of going to need it now for the pure function as an object. So our article now freezes the title, so there's no way you can change that string. Well, there are ways, but let's assume there are no ways and that your team behaves well and you actually are not able to change that state. So now we can work with this article that is actually immutable. And so now if you run, I don't know if you remember from the callable class, but we had actually gsub, which is using a bang method. And that's actually trying to change the title in place. So it's mutating that string. So now it won't work because the string is frozen. So how are you going to do to solve this one is actually not mutate stuff. So as we will see, our click biter now is a bit different. So first thing first, the call is pretty much the same, but according to the pattern that I see online, actually people try to make initialize private. You can still initialize the class, but that gives a pretty strong idea for anybody that reads the code that you should not instantiate this class. So that's actually a good thing. That's why I put it here, because we don't actually do this at NomNom. And you have the same thing, you get the article, and then you have the call method that changed. Basically, now we are not mutating the article, we are just returning a new one. And this is a pretty normal pattern that you will use if you are trying not to mutate state when you're using an object-oriented language. There are exceptions, of course, but it's super cheap to instantiate a new object, and if anybody is interested in the same object and is running concurrent code or something like that, then people will keep the same reference and you can live forever happy with your new version of the object, which is a pretty good thing. So at NomNom, we are actually doing some stuff that is different, and we have this big argument that I'm actually showing here for you guys to know that this is not you should not take this for granted. There are ways that you can work it for you, make it work for you actually. So this is the classic one that we've seen so far. So we have basically this one here is actually one of our classes that just creates a comment for an island. So highlight is basically, if you used Medium before, you can highlight a bit of text and you just get a pop-up that you can share online. We have kind of that thing, so you can do the comments on that. And basically, if there's a response, we just pass that response. So we also have this discussion where we actually, as you can see, the private method, the initialize method is not private now, and we actually pass the parameters for your controller here, and then we call. But from this moment, you are calling more than one thing inside your class. So it's actually it's holding state inside, which is not that good for a functional approach to this. So we have big fights internally on how to actually pull this one off, and we are moving all these services to the other version that I showed before. So we are trying to get to this, but this has some problems. So your response might just bring you the response that you want to bring, but what if you have errors that you want to load different from errors that you want to send to your API and stuff like that? It gets complicated, so yeah, there's some fight here. Okay, so what I have here next. Okay, this is actually one of the solutions that people usually use when they use this pattern. It's actually you create a structure that holds the values that you want to return from your, in our case, handlers or services or whatever. One thing about this is why I'm using struct everywhere. First, we like structs, for no particular reason. It's really easy to get a new class that actually receives 3 arguments, and that's good to go. And another reason is that it actually it shows you that okay, this is just a struct. Not in Ruby, it's not like that. You can actually do more stuff with that, but you should look at it as just like if it were a value object. We also have value objects, but when for these simple examples, struct will do most of the time. Okay, sorry. Any questions so far? I'm probably going a bit too fast. So all good? Cool. Okay, so next, Prockable. This is the one that I have the most fun with. So this is actually, some of the ideas come from this at Lexus. You can check it both on Twitter and on GitHub, and he has a presentation that is actually pretty similar to this one, but actually mine is similar to this one, but it's pretty good, and you'll learn a lot of stuff there. So, okay, Prockable now, it's just super simple thing. You just implement to proc. That's it. In our case, it's just on class level because it's we don't want to instantiate the class, and that's it. You'll have a lot of behavior with this that you'll see in a minute. So I think a good example for this is actually this one. So this is an example where we have an array of articles, and where okay, so you have the article new with the first title and the second title. This is a new version of this is the same version of the article, and we just map click right on it. Why does this work? Anybody knows why this is working? because I'm just passing the map like a class name, basically, like, no? So, like, I wanted somebody to answer, so I didn't have to.
Ruby calls to proc.
Yeah, thank you. Exactly. So yeah, Ruby is going to call to proc. So if you saw before, we have an implementation for to proc that actually is returning the only and single behavior of this object or class. And yeah, so basically this works. So this would be the result. Again, you can see it like from all that. Just assume is correct, which is always a good way. So here comes another discussion inside like NomNom, where we have discussions all the time, like composition over inheritance. We are using functional languages, so we do prefer composition. But funny enough, in Ruby we are, or on Rails in our case, we are using composition. So this is an example of something that you could do. Like it's not even fully implemented, but if you wanted to have this behavior in all your classes, you could just include functional object. And it would basically create these methods for you. This is, I'm not like, I think this one would work, I think, but still. You would have the call method as a class method, and okay, it misses the toProc, but you get the picture. And another example, which is how we do it, is actually we just have a big hierarchy of classes, because people are against inheritance. I'm against inheritance when you like have a big team, but we have a small team, and it just brings a couple of methods that we need, and that's it. So for us, it's a super simple thing. So we kept the inheritance there, and actually working super fine for us because we don't do much with that. But again, just to show you that you can implement like a functional patterns in Ruby in the way that fits you the most. Like I'm not at all against object-oriented. The object-oriented paradigm is just this one makes it easier for me to reason, and I think for my team members too. So we did an effort to change that. Okay, so this is actually an example of how we do it at NomNom. Like, as you can see, we are like pretty hardcore on modules because for us it's super easy to know what is happening. We just look at there and we know, okay, this is an handler that is called from the API that is creating another. Like it's trivial. And again, there's only one function that does that. A single function creates everything for us, so that's fine. And now, towards composition. So this is the bit where this and immutability is where, for me at least, you stop writing idiomatic Ruby, like that click where, like where you are iterating and passing the class name and implicitly calling to proc. It's not the most idiomatic way to write Ruby, but I think it's pretty cool, so I like it. But on composition, there are some caveats. For me, the biggest one is that you might have to multi-patch, but we'll see. Okay, we have a new requisite for our model of the click waiter, and we actually article now also takes an entity. I don't know, like if you know what like on natural language processing, you can do this thing like this. This was the crazy idea that I did for here, but anyway, we can do this thing which is like you can get the entities of a text. So, for example, on the example of La La Land is obviously the entity for us. It's harder to do in code, but let's imagine that we just get one entity for title and it's there, just for the sake of this example. So, I will click waiter now. We'll have another requisite which is not only we will put a question mark in the end of the title, so you have more clicks. You will also change whatever entity it finds to Donald Trump, so you'll get even more clicks. So that was the example that I wanted to use today, so why not? And yeah, there's not much below, but just to show you, just hands there. I don't know if I can do it. Yeah, cool. So you basically have question eyes and you have Trump eyes, and now our call method, basically our old function now is doing more than one thing. There's not actual side effects, but it's like definitely like if you even in object-oriented way you have this is for everyone actually. It's like you have the single responsibility principle, and you just don't want all that behavior there. So that's the first code smell. The second code smell that Terpena is actually using the attribute reader that you would get, and QuestionEye is actually getting an article as an argument. So because you need one depending on the other, so this is not the best way. So let's try to simplify that. Oh? Okay, I need to this would look like, for me at least, this would look like way better. For me, the best part is actually declarative. You know what comp is doing. It's basically calling questionize and trumpanize, and that's it. Like this is where we want to go, and this is like for me the most beautiful thing on composition. So it gets super easy to see what's happening, and like we actually can get this from Ruby soon, because there's this pull request for proc, and you could just call to proc on those two and it would work. The problem is that there's also this thread that is being like discussed for 5 years now, and well, 5 years have gone, and like I think the biggest problem from what I've read is actually they can't decide which method they want to overload. Crazy. So a lot of people like you know, double bigger signs. Other people like the asterisk. So whatever. There's like, for me it's a missing bit on this language, because I don't know if you're doing JavaScript, you can, I don't know if you used Lodash before. Lodash brings you that. So I don't think active support has this, because if Lodash has it, active support should. But anyway, so you can actually like see an example. This is actually S6, but same thing. You have two functions and you just call flow. Flow is the way you compose functions with Lodash, and it's super easy. As you can see, you can compose a new function just by calling flow and passing the name of the functions, and then that's it. It just works. The first one is just appending num to whatever you pass it. The second one is just uppercasing, and we do a flow, we create a new function. If we pass up num, it just does num. It's super easy. This is an example of in Clojure. I had to, because like again, Clojure have like a lot of different ways to do this. I think I just bring two, unless you want to go all combinatorial and you have a 10. So basically, I'm requiring string because uppercase comes from the string model in Clojure, and basically I'm defining a function that takes a string and appends num to that string. Another way to do that is actually partial, just that thing, which is super easy. You can just partial format, and it will basically create a new function where the first argument to format is there for you. Don't worry about it, and then you can just pass like for the up num function, you can use this arrow notation. It's like, I don't know if anybody's doing Elixir, but it's pretty much the same thing as the pipe operator. Yeah, and actually bash, you can do the same thing, where the first argument that is passed to the function is actually s. So s is like the argument to that arrow thing. Append num will get s as an argument, and then string uppercase will get the result from append num as the first argument, and that's it. There's even a simpler way where you can just do Clojure as this thing, like the asterisk in Ruby, where you just call comp, and that's it. You have a new function. But yeah, we are not here to talk about Clojure, so let's move on. There's this solution for Ruby from Tom Mortel, and is actually overloading that the asterisk operator on proc. We will assume from now on that this exists. We like here separate from NomNom because we are not doing, but I just think you get a better idea of how declarative functional programming can be and how less state you can keep in your head if we just assume that this is there. So this is again exactly the same example if Ruby implements the method. So I think that would be pretty cool, and you can like append upper would be super declarative. Just say, okay, this is the composition of this function, and that's it. So, okay, this is how actually we are solving it in NomNom, because you know, like from years now that there's a lot of blog posts talking about not overloading like core classes and stuff like that. So we don't want to do that, and so we are delegating for. Like basically what we do is like we have creator is create a call with the result of append out, and then we delegate to another one, Sometimes it gets harder to read, but like we have hopes on some like pipeline operator. So there's some gems, but like I don't know why we never use it, and now it's a bit too late. Like as you saw in all those modules, we have a lot of namespaces to change now, so a bit too late for that, at least for now. Okay, so let's refactor that class again. So we have a new class called questionize, that the only thing that is doing is again the same thing, replacing the final dot with the question mark. We have the trumpanize, where the entity byte is trump, and we are basically like taking the existing entity from the title and adding trump there. And so, like on the top, you would have like the call into proc again, and then now we can actually like see like what is vectorized is just apply questionizer and interponizer. This is what I like on functional programming, or at least what we can get from Ruby, is that we could get this declarative. It would be like easy to read, and that for me would be like pretty cool. Now we have to delegate, but still this, if they implement that operator, or if you want to overload proc, this is what you will get. And now clojure, actually it still has, if you look at it, you still have the same problem where you are doing more than one thing, but you are basically like always delegating to the other classes because you are just composing functions. So, like for example, I have to give again the example on clojure, this would be all lazy. So in clojure we will never execute any of the functions, and just the last function would like execute when you needed its value. So all the functions would be executed at once. Ruby doesn't do that, but anyway, I think it's like it gets way easier to reason about code, and your classes get smaller because I'm hiding colon to proc there, and we actually don't have it in NomNom, so it gets super easy to see what a class does. Okay, so just this one we are not using for sure, but I think it's a fun one and it has to be mentioned when you're talking about functional programming, which is currying. So like currying is basically you create a new function by the previous function by replacing one of the arguments, kind of. So imagine, like I think I have an example here, but imagine that you have this function initialize gets replacement in article. If you curry that function, return one argument, you get a new function that just takes article, and it kind of holds a replacement for you to use later. So this is pretty much what currying is. Like there's explanations online that probably go against what I said, but this is how I understand it, and it has been working for me. So this is a class that I created just for you, just to show you the power of currying. So this is entity replacer, basically the same thing that tramponize was doing, but now you can pass a replacement. So instead of tramp, if you wanted to talk about, I don't know, like Obama, you could pass Obama as a replacement, and you will do exactly the same thing, replace our entity, but for Obama this time. So you could get to this. So you could use exactly the same thing that we used before, the same articles. You could use entity replacer like this. It's a bit involved, but basically to call curry, which is Ruby gives you for free, you need to have a proc. So curry is implemented on proc. I'm not sure if there's more classes implemented, but the only one that I know is proc. So you could actually get the proc from entity replacer, and if you remember, that's the call method, and you curry it and you create a new function that has the first argument as tramp. Just to remind you, like it's the same thing as creating a new function that this argument is fixed.